they were infected, they could self-isolate to reduce the risk for spread. Now away, detecting the earliest signs of COVID-19. There's an app for that. Just like ships have sonar systems on board to detect approaching obstacles, our lungs and airways can also send signals of distress through what's called reflective sound waves.
Depending on how much the airway has been changed, this will basically change the pattern of the reflected signal, and such pattern changes could be measured by our speakers and the phone's computing power.
Using standard tools found on a smartphone, the speaker and microphone, Dr. Wei Gao and his team at the University of Pittsburgh developed a mobile COVID-19 sensing system.
People can use this as a daily, convenient, and non-invasive tool for self-evaluation and self-diagnosis.
Here's how the system works. Users breathe into an attachable mouthpiece, generating sound waves that travel through the airways to the lungs. When they reach an obstruction, like inflammation, mucus, or narrowing, reflective acoustic signals bounce back.
If you have a certain problem in the lung, there could be certain inflammations which will narrow the airways, and thus narrow the airways will produce extra reflections. So the reflected sound will be captured by our microphone and be analyzed.
The non-invasive at-home monitoring system is not designed to replace standard viral testing. Instead, the technology may help reduce the burden on the public health system, particularly when it comes to testing.
The United States has done a huge number of tests, but essentially a very large portion of such tests eventually comes out to be negative. This technique can never be a direct replacement of the clinical diagnosis.
Dr. Gao and his colleagues are still in the pilot phase. They've developed a prototype which includes a 3D printed trachea so they can tweak the system in the lab. Next up, testing it out on humans and ultimately patients in the hospital.
We're very happy that we find out this opportunity which could possibly contribute to the fight against the virus.
Dr. Gao says the technology can ultimately be applied to other acute or chronic respiratory diseases in addition to the novel coronavirus.